हाँ यही है। Good morning, sir. You are the host now.
Oh, okay. So let others join, then I will start.
Okay,
Good afternoon, everyone. Can you hear me?
Yes, sir.
good afternoon.
Good afternoon, sir. Good afternoon, sir.
So let us start with the today's session. So today's session we have a for shorter duration and its application to radar. And what I'm supposed to cover in this topic is little bit introduction to AI and then how we can use AI in application to radar. So this part we'll cover in this day. So once I complete the lecture, we can have a small break and then we can start with the exam. And after the exam, we'll go for declaration of closing of this workshop, followed by certificate and other things we'll go for display. So this is what exactly we plan for today's session. So let me start with the concept of what I am supposed to cover today. So today class, we are supposed to cover on AI. So starting with the introduction to AI, I given a title of artificial intelligence, a magic wand. As you are aware, I'm the my name is Badri and Subudhi, and I am from Department of Electrical Engineering at IIT Jammu. So this is IIT Jammu campus actually. So this campus is just 9-year old, new IIT in central funded institute and newly established IIT with a smaller department. Coming to the concept of AI. So the concept of AI started in 1950s, or even the concept coined before long back. Practice or in practical point of view, it came to picture in 1950s actually. And the idea was to make the machine powerful, or you can say in other way, the way to make the machine exactly copy the behavior of a human intelligence system. In other words, we can say it as the way human intelligence behavior performed by any normal human being or a advanced human being, if we can copy the same property by using a machine, then we can say this concept is called as artificial intelligence. Or in broader way, you can understand that the aim of any AI algorithm or AI technique is to copy or exactly replicate the human intelligent behavior in a machine. And this part of is supposed to be previously understood as a part of robotics, actually. But later on, people understood that the AI has many components, starting from robotics is one of the important components. Similarly, the concept of AI is also coined by uh, Professor Marvin Minsky from AI lab in MIT. So what he mentioned that what is AI? Science and engineering of making intelligent machines is the concept of AI. And what exactly intelligence is mean by him is the ability to acquire and apply knowledge and skills. So in other words, you can understand that the human knowledge and skills, if you can apply to a machine, then Professor Marvin Minsky mean to say that it is the concept of AI, and this is what exactly a machine is supposed to do if you want to make him powerful. So later, many concepts came into picture where people have started using the concept of AI in robotics, self-driving car, voice assistant, mobile phone, whatever you are using, or display devices you are using, or kind of analytic system you are using in your car. All these are healthcare industry where autonomous, you can say you are capturing the MRI, you are capturing the ultrasound, And you are predicting by using the machine the size of the in case of ultrasound report. So these are also part of AI application. Similarly, in consumer electronics, nowadays, even you can control the temperature of the fridge, even you can control the AC temperature from your office, and also you can control the quality of food, or if you want to check how much your food is preserved, that also you many of the financial advices, stock market prediction, that is also possible nowadays by AI. So AI is now vast. Automobile, robotics, self-driving car option, voice assistant option, healthcare option. Only few area to say, but it can be applied to several fields. Now, if you consider the latest concept, AI has now been shrink to deep learning area where the complete AI umbrella was previously containing a small umbrella of machine learning, and now it is boils down to deep learning as a small part. So in other way, you can say where machine learning is another subset of AI. So the complete concept of digital will include the AI concept, which include machine learning and deep learning are the pivotal role, or you can say primary role applicable to several industries. Now, before going to all these technique, or you can say deep learning technique, which is the latest in the industry application, we should know what exactly machine learning means by. And it is required to mention here that deep learning is a kind of algorithm which is also part of machine learning. So in other words, you can say deep learning is a smaller umbrella under the machine learning main umbrella. Now let us understand the concept of machine learning. So the concept of computer science, or you can say electrical sciences, which is giving the computer the ability to automatically learn without being explicitly programmed. So the idea is that if you can feed some data to your algorithm, so the algorithm without explicitly program, if can automatically learn from this data, then we are saying the concept as machine learning. So just try to understand. Let us assume you are looking at a trend of particular stock market data. So stock market data, you might be knowing that particular stock is every day increasing by, let us assume 2.5 rupees or 3 rupees. So trend says that after certain days of time, the trend, if you can model by machine learning algorithm, so the way human predict that this stock is supposed to increase, at the same algorithm in case of machine, then we are saying the concept as machine. The complete machine learning paradigm is divided into two parts. One is the training part, another one is prediction part. So in the training process, the data what you are exactly considering, it is fed with the machine learning algorithm whose level or outcome of the data is known. So something like, let us assume you are given with one example that a particular stock has this price. So you are aware that this price is increasing price or decreasing price. So you have proper idea about that. And we are saying this as training sample. Other example, so you can think of every day you are coming to your office and you are giving a biometric attendance system to mark your attendance. So in the initial days, when the machine is newly purchased, you are provided with individual person face or biometric data with tag to prove what is his name. So that means out of biometric data, and level is to say that, or class is to say that what exactly this person data is, or whose data this one is. And we are saying this are training sample. We try to plot a probability distribution function, or you can say try to put it on a feature space where biometric data to separate out this person specifically. Now, exactly same way in the prediction process, next day when you are coming to your office, you are putting your biometric is you or not. And this complete algorithm is called as machine learning. Every day you are coming to your office, different person is showing their face to the system, and it is saying that exactly it is doing. It is trying to consider individual person biometric data and predict or project it into a end different object or different person. It will try to segregate. This is person one, and this is person three. So like this, if you have 100 persons are there, then 100% data are separated by using this learning space. Next day, when a new space, and wherever it is lying, so let us assume if you are lying here, person 100 based on the position of the projected data. And this complete algorithm is saying as machine learning. Now, machine learning has a different paradigm. So, what data is available, and based on the training data, you are trying to learn the system. Whereas, in case of unsupervised learning, you are supposed to learn the system. And whereas a reinforcement learning, you are trying to reinforce the information to learn the system. And based on this criteria, you are having supervised learning, unsupervised learning, and reinforcement learning are the we are dealing with. We are dealing with only the case of supervised learning. Or you can say a classic popularly used for most of the machine learning applications. Now, one of the biggest challenges in machine learning system is traditional ML system. The problem is that when you are trying to feed your data to any machine learning system for classification, one of the biggest challenges is that what exactly observation or measurement will take on the object so that it can be classified properly. So in other words, you can think just when you are giving a biometric data, you are showing your face, what are the distinguish you from other people on that area or on that machine who are giving attendance. Right, pupil distance or eyes size, or you can say distance, forehead size. So these are many features, or these are the many measurements you can take to consider a dimension, different dimension data to project it into n-dimensional space or distinguish a person from the biometric data. If your dimension of the data is too high, if you are taking lots of observation, may not be always Reason is that it may be possible that if you are taking hair of the hair color of the person, or you can say pupil color of the person, skin color of the person. So you will find that if you are taking some measurement like this, there are many persons are there who are having similar measurement, or you can say they are very much similar to each other. And for any machine learning system to distinguish between the person. And this concept is called as curse of dimensionality. And if you go on increasing this information or this measurement, this will nothing do. Rather, it will try to confuse your classifier or a machine learning system. And later on, you will find that this will create a challenge of managing the data properly. There is a phenomena. So what exactly this phenomena is saying? The power of a classifier or a regressor first will increase as the number of dimension feature used to increase, but then it will start decreasing. So let us understand clearly. So what exactly it says, if you are taking different observation on the data, putting it into a classifier, so you will find that initially the classifier performance will, but later on, when you go for adding more amount of that slowly the classifier performance or the machine learning system performance will slowly go for decreasing. And these are few applications where it is already proved, like speech recognition or object detection. If the number of features you are feeding to the classifier will go on increasing, slowly the performance of the classifier will go for decreasing. And this phenomena is called as Hughes phenomena or picking phenomena. The problem is defined. Considering this phenomena, what exactly it says that many systems are overspecified. Overspecified is to say that you are giving the data which are not required and you are forcefully putting it into your machine learning classifier. Similarly, mostly the ML system, what is done, these are application dependent. So application dependent is to say that when you are putting any data to machine learning system, it is defined for particular application. Something like you can understand. If you are feeding a biometric data, it is for face recognition system, I have to put different type of measurement. If I'm going for identifying a vehicle from the person to a, you can say, animal, that also required another kind of features or another kind of measurement or another kind of observation to be taken on the data. And second thing is that it will be very time consuming in design and validation of the model. So if you have designed any kind of machine learning model, it is quite time consuming for design and validation of it. And last but not least, developing handcrafted feature is doing. So these are manually defined and manually choosing single application or single measurement on the data is quite challenging or complex or costly job. So traditional machine learning system, what exactly it is doing? It is trying to take the data, feed the data to a system where handcrafted features are extracted. What do you mean by handcrafted feature? You are taking manual observation on the data or manual modeling of the data so that you can extract more amount of information from it. Exactly same as that of what will be the nose height, what will be the pupil distance, what will be the lip size, what will be the ear shape, what will be the forehead distance or forehead shape, or what will be the distance of top to chin in your distance, in your case. So these are called as the measurement you are taking or handcrafted picture you are extracting from the image itself, or you can say what kind of data you are taking for. And you are feeding this data to a machine learning training system to train the model. So once you are able to train the model, in the latter stage, whatever data you are giving, you are supposed to get an output correspond to the prediction of the machine learning system. And this is where deep learning came into picture. As we have highlighted, the machine learning system are overspecified, incomplete, mostly application dependent, time consuming due to design and validation, and developing handcrafted features are quite challenging. For that reason, people thought of going for alternate arrangement, and that alternate arrangement is your deep learning model. What exactly you are using for today leadership. And deep learning is nowadays used everywhere. So if current days you are saying AI, that AI is completely replaced by the concept of deep learning. And this is applicable starting from internet cloud or IoT application, you can say, medicinal biology, media and entertainment, security and defense, and autonomous machines. So everywhere nowadays, wherever you are looking for any kind of application of AI, it is exactly using the concept of deep learning. Now, Geoffrey Everest Hinton is called as cognitive psychologist, a computer science and researcher at Google. So he has got for many award for inventing the concept of big deep learning. The breakthrough happened for deep learning is with a, you can say, invention of mainly backpropagation algorithm in 1970, 1995 Lenet 5, 2012 AlexNet model, 2014 BGC16 model, and 2015 ResNet 50 architecture are the primary concept which came for deep learning. And based on these algorithms or these models, later on this deep learning technology is now in very high advanced stage, and these are popularly used for several applications. Now, what exactly deep learning is doing? As the name defines, deep and learning. So it says that you are going for a machine learning concept very deeply, or you are trying to learn your classifier in a deep level. So what exactly saying that? It is using multiple levels of feature learning or multiple levels of observation learning to learn reach hierarchical representation of feature automatically. So what exactly it is doing? If you are considering a particular person face, it is trying to extract multiple level features. In the initial stage, it is trying to consider low level features. Like you can understand the structure of the ear, the head structure, the hand structure. So these are called as, for me, low level structure or low level features. Second level, it is trying to consider eye shape, nose shape, the direction of lip, definitely measurement for forehead height, then chin shape. So these are going for mid-level feature. And in the next level, it is trying to go for high-level features by direction of hair in the eye area, the fur area, what will be the color or fur area directions, or you can say shape of this eye pupil. So these are called as high-level features. And in this case, only three-level features you are considering or three-level measurement or observation you are doing. Now, if you increase this observation to n number of levels, you may able to extract multiple level features out of each data you are feeding to a machine learning system. And this multi-level feature will go for representing the feature in a hierarchy. Learnable and representing mostly the fine-grained feature which is required for your feature learning experience. And this is where exactly deep learning works. Now, previously, if you compare observing, let us go with an example. Let us assume you are giving a picture of a vehicle and asking your computer to go for machine learning algorithm to detect what exactly this picture is for. Now, what machine learning system was doing, it is trying to initially extract features from here or taking the observation on this data. Now, what exactly this observation it is doing? It is trying to take what are the measurement on it, and these measurements are fed to a machine learning system like neural network, you can say. And this neural network system is trying to predict it is a car. But what exactly deep learning says for your data? Because this system will work to recognize whether it's a car or not car. But tomorrow, if you are using this data for firing purpose or to use it for some other application, or this feature will be useful for some other application. And that's in case of machine learning. And what exactly they have done is they put a single module which is composed of a deep level neural network. So previously, very shallow level neural network was there. Now you have a very deep level. You are going for multi-level feature learning through the network to extract the feature and classify all together. So here, the feature extraction and classifier or classification will happen in a single stage. So you are feeding your data, it is extracting what is the required feature for your application, going for classification. You are specifically mentioning these features you extract for machine learning classifier to learn it as a car. But now you are having, real system. What exactly it is doing is, it is going for two stages learning process. One is feature extraction module and another one is classification module. So where automatically it will learn which measurement or feature are required for you, whether it's a car or not. And these are automated iterative process where automatically it will iterate and learn over the data to recognize whether it's a car or not car. Now, this concept is a part of a neural network actually. So we must be aware of what exactly neural network was there and what exactly its disadvantages there so that people thought of going for this deep learning concept. So the concept start with perceptron algorithm, which was proposed by Frank Rosenfeld and in 1957. Some hardware to simulate the human neuron system. Now, what exactly the biological neural into a computer-based program and later to a open circuit to represent the biological neural network. So he says that every human being is composed of billion number of such network connection or very massive parallel network connections. So where the main body contains a nucleus, which is the main material which is composed of this nucleus. Now, what exactly it says that when a human wants to do any specific task, some amount of hormones will be released from this neuron or nucleus of the body or nucleus of the cell body. Now, this hormone or this pulses or this hormone will be transmitted from one neuron to another neuron through the axons. Now, what exactly it says that when these hormones will be transmitted from one pulses, and these pulses information between the network. And it says that if it exceeds, will fire to the next neuron. So if this nucleus or if this neuron will fire, then other neuron will get the information. And if it exceeds, otherwise, it will stop there. And based on the kind of activity a human do regular life, like you are brushing your teeth, eating your food, walking over a road. So all these things
Sir,
happen due to firing of neurons in the network.
सर आपकी आवाज ब्रेक हो रही है.
So can you hear me now?
Yeah, sometime
It's
it is
break.
cracking. Otherwise, it is okay.
Okay. Okay. Okay. I hope you can hear me sound now.
Yes, sir.
Okay. Now implement simulator model, it is represented as some kind of network like this. So what exactly it hold? There will be a cell body which is connected from many number of neurons from the outside. Now, what exactly this connection says? It is sending the information from the previous neuron to this neuron by synaptic connection or dendrite connection. And if this one is X0 and synaptic weight connecting it is W0, then amount of information coming to the cell body or nucleus will be W0X0. Similarly, W1X1 like this. And the information what exactly you are getting here, it will be sum of a bias value. And linear classifier model, or you can say an equation which is projected in n-dimensional space to separate out the object in an n-dimensional space, which is called as f of w. And this is what exactly perceptual model is meant for. So you have input x through a way w1, w2, wn minus
The signal is breaking. We are not able to
wn.
hear.
You have a constant. Okay, let me get reconnected. Give me some time. Let me. Kindly make me host or co-host. Hello. Himanshu, can
Yes,
you
sir,
hear?
I am making. Yes, sir, I am. अरे यार, sir, it's done.
Okay. You can see my slide. I hope you can see my slide.
No, sir.
No. Okay. I
Yes,
hope
sir. Now
now.
it's visible.
Okay. So let me continue from that part. So what exactly I was saying that,
Sir, please repeat the previous slide.
again.
Yes, sir, because your voice was breaking at that time.
So shall I start from this slide?
Yes, sir.
Okay. So the concept starts from here like this. A human brain contains a lot, or you can say a billion number of neurons. So these are very massive parallelly connected neurons, and these are responsible for most of the regular work what we are doing in our regular life. So what exactly it says that each neuron, if you consider, this is composed of a nucleus or cell body, and these are connected to another neuron through a dendrite or axons. So what exactly it says that, let us assume you want to do your regular activity in our home. So what exactly we are doing is, we are sitting, walking, taking food, or we are doing picking the water bottle, we are taking the water glass, or we are writing something, or we are typing something in our computers. So what exactly these neurons are doing? These are sending some signals to different part of the body. So all the human brain are composed of such neurons. So these neurons are responsible for different part of our body. So few parts are responsible for our hand, few parts are responsible for our legs, few parts are responsible for our shoulder, few parts are responsible for our mouth. So these are the control mechanism which is controlled by these neurons. So what exactly happens is, when a human think anything, let us assume we want to pick a glass of water. So the brain initially composed of neurons connected from our vocal cavity, which are feeling dryness due to thirsty. So they will try to send a signal to the nucleus, and these will start firing first. So in response, these nucleus will release some hormones to the different neurons in the body. Now, if these neurons are connected from the thirstiness, then from our childhood, it is learned that this thirstiness can be removed by giving a signal to the hand to pick a water glass or pick a bottle of waters. So the neurons which are connected to the hand will get a signal from this hormonal activity, and this hormonal activity will travel or pass through by sending impulses from one part of the brain to, or one part of the neuron to other neuron. So neuron is transmitting the impulses to different part of the neurons. so that those neurons connected to the different part of body will go for activity. Now, if it doesn't exceed a predefined threshold, it will not work on. If it exceed a predefined threshold, then only you will get a work activity in your body. So something like if you are feeling thirsty, the brain neurons which are connected to the vocal cavity or a you can say gland connected to thirstiness, these will get first signal to the hand to pick a glass of water. So before that, it will send a signal to human eye to check where exactly water bottle is there. Within a fraction of seconds, all these signals will try to be propagated different part of human body and send the signal such that a water bottle will be picked and a person can drink water. Now, if you go for this network representation, Rosenfeld, what exactly he tried first is he tried to simulate the same model by a mathematical model. So where each action from where the signals are coming, these are represented by input x0, x1, x2, xn. And these are connected by some synaptic weight W0, W1, W2. And when these dendrites are connecting from different neurons are sending signal, it will coming to the nucleus, and this nucleus is nothing but summation of weight correspond to this dendrite multiplied the input coming from that other neutron or nucleus of the human brain. And these are combined with some bias value to represent the combination of the impulses or hormones coming from the other neurons. These are combined, and if it exceeds a predefined threshold value, then only this nucleus will go for firing to the next stage. And this firing process or thresholding process with a predefined threshold is given by a function f for me. And this is what exactly called as single perceptron or neural network model, which is used for representation of your data transmission in human brain. Now, if you want to represent this model, so what exactly you are doing is you are considering x1, xn minus 1, xn are the input coming from the different neurons, which are connected to the current neuron by W1, Wn minus 1, Wn are the weight value. Now, from our childhood, when we learn that when we are feel thirstiness, we are picking the water bottle by some mechanism. So, or other mechanism is that you are asking some person to hand over a glass of water or glass of water bottle. Now, all these things happen in a fraction of time in our brain by considering that these weights are properly learned. Because whatever the activity you will do, whether you will give a signal to the mouth to say the other person, please give me water, or give a signal to your hand to pick a water bottle, or you are supposed to ask someone, please give me water. So all these activity are controlled by which part of the brain will active by giving these weight values. And these weights are combined so that information will be passed to the next stage of the brain by or next neuron connected in the brain. And these are controlled by a predefined threshold value, whatever I am saying, this is a threshold function. And if you consider this criteria, this is nothing but xi w0 or x1 w1, x2 w2, xn minus wn, xn wn, or in turn, you are going for x multiplied by w, a vector, plus a constant w0 to give whether it's greater than threshold or not. And this is nothing but a straight line equation representing a classification of data in an n-dimensional space. Now you are trying to adjust your weights so that at a particular time, you are supposed to classify what are the activity you are supposed to do. And this is what exactly a single perceptron is doing in the brain. Now, if I will go for adding few more layers, so previously I have only one layer is there. Now I am adding two neuron with two layers of weights. So here, first one is giving S1, there is a single straight line for first one, and second one is giving another straight line. Now, if you go for intersection of both line, it will create a plane for you. So which will try to separate out the S1, S2 combination as representing a particular convex plane, or you can say a layer to represent the structure. Now, if you go for adding more number of layers to it is nothing but many such straight lines are cascaded to prepare several planes or combination of planes or hyperplanes. And these hyperplanes are responsible for separating your data from different person to person, what we have given example for biometric data. So like your face is here, another person face is here, another person face is here, one person face is here, one person face is here, one person face is here. So like that, you can consider several person to be identified by using such a massive connected parallel network. And this is what exactly you mean by neural network, what people used to do for different work of starting from different animal classification to different application of human face identification for regular life. Now, this concept is supported by Lateran, a algorithm developed as backpropagation algorithm, which is used for update the weights correspond to the weights of the neural network. So, which was proposed in universal approximation theorem in 1989, and later on in 1990 to 2005, this model got its popularity. But case is, such model never goes for longer distance. Rather, later on, it is overcome by many such network like distant tree, stagnated network, DVN, nonlinear SVM, and later on, many of the deep learning algorithms came into picture. Now, what exactly came into this picture is that there was a popular challenge for image classification. And this is called as ImageNet challenge. So what exactly this challenge says that you have almost 14,31,167 images are there. And you need to classify these images of different object of 1,000 type. So that means it has car images, it has bird images, it has animal images, and many other images are there. And these number are 1,000. So 1,000 different type of images are there with 14,31,167 images. You have to classify these images into 1,000 different varieties. And this is a kind of popular challenge called as ImageNet challenge or large scale visual recognition challenge. Now, previously, when deep learning concept didn't came, with neural network the concept what we have discussed now, people got an accuracy with 28.2% error. 28.2% error is to say that this was giving an accuracy of 72.8%. Later on, it came down to 25.8% error in 2011. And when this deep learning concept came with 8 layer, or you can say 19 layer, 22 layer, slowly from 2012 to 2015, this error is reduced to 3.57%. So you can think of use of this deep learning concept has tremendously improved the classification accuracy. And this was possible due to the concept of deep learning algorithm or convolutional neural network concept. So previously, whatever the concept is used, where each neuron is connected to other neuron by using a multiplication process, now CNN or convolutional neural network instead perform to go for a matrix convolution operation rather than a multiplication operation to replicate it. And this architecture is represented something like this, where you have a input images there, and you are going for a stack of neural convolution process, pooling process, convolution and pooling process repeatedly applied to go for extracting multiple level feature learning. So what we have studied earlier, that you have multiple level of feature extraction and learning processes there. This is what exactly you are doing in case of CNN architecture. So you have a input images there. You are applying a convolution ReLU and pooling operation repeatedly over the same image. And from there, whatever feature you are extracting, you are flattening it, putting it to a classifier to go for deciding what kind of image is there. That is 1,000 different types, starting from car, truck, van, bicycle, human, animal, all these things you are supposed to distinguish. And this convolution operation is performed something like this. So you have an image of n-dimensional space. You may understand that you have a red, green, and blue channel in the image is there. You are putting a kernel function like this. And these kernels are supposed to be defined by randomly users. And later on, you are supposed to train the model or the weights of the model, what you have understood previously. These weights are represented by kernel functions. So these kernels are fitted over the input channel red, green, and blue to extract the information and combine to get an output. And this operation is called as convolution operation. So you can understand something like this. You have a 32 cross 32 size input image with 3 channels. You are using a 5 cross 5 cross 3 filter, and every time we are putting the kernel to combine it to get an output of 28 cross 28, which is called as an activation map. And if you consider several such filters, let us assume I am applying 6 such filters. So from these 6 5 plus 5 filters, I am supposed to generate 6 activation map of 28 plus 28. And these activation maps, what you are getting, this is nothing but by different convolution layer, you are extracting low level, mid level, and high level features out of it. And the way you have extracted these features, it depends on kind of strides you are using. So if you are considering a 7 cross image with a 3 cross 3 filter, and you are putting your slides every other pixel, then you are saying stride equal to 1. So something like this. So every pixel location, you are putting the kernel and getting the output. Now, if you are shifting by 2 pixel, we are saying stride equal to 2. And if you are putting stride equal to 3, you will find that it is not fitted. Reason is that when you are putting a stride, or you can say you are sliding your kernel over the image, if it is not going to fit it properly, then you are supposed to get something like this. You can understand that output size of particular stride is possible if you are having n minus f divided by stride plus 1 will be an integer number. So if I am considering n equal to 7, stride equal to or kernel equal to 3 size, then you are considering 7 minus 3 with stride equal to 1, 7 minus 3 by 1 plus 1 equal to 5, 7 minus 3 divided by 2 plus 1 equal to 3. But when you are considering stride equal to 3, it is supposed to give you a 2.33, which is not a possible operation in a kernel space. And that's why this stride is impossible, and it says avoid this type of operation for convolution. So convolution is mainly dependent on kind of stride you are taking and convolution process you are considering for your operation. So let us take a break now. So as per schedule, let us take a break. Then we'll meet again at 2:15. Hello everyone. Hope you can hear me. So if you have any doubt till now, you may ask now. Then we'll start the second part of lecture. Hope you can see my slide.
Yes, sir.
Okay, anyone is having any doubt or anything, please let me know. Okay. In that case, let me start with the concept. So what we have understood is that we are putting a kernel at every location, sliding over all the pixel in the image and going for point-wise point multiplication and addition of all the point to represent the final output of convolution. Now, for doing that, what I mentioned that if you have a 30 cross 2 cross 32 cross 3 size image or 32 cross 32 cross 3 type matrix is there, and if you are going for a 5 cross 5 filter, you are supposed to get an activation map of 28 cross 28. And if you are using such 6 kernel or 6 masks, you are supposed to get 6 activation maps. And these are essentially represent the different level of features what you are extracting from the neural or CNN algorithms. Now, what exactly it conveys that if you are going for one after another layers, then you can extract low level, mid level, and high level features at a different level of convolution process. And this is what exactly mean for multi-level feature learning, what we are interested earlier. Now, this is supported by the concept of stride, which says that when you are doing convolution at an image, how many pixels you will slide over by the kernel on the image. And this is represented by strides. So you can see here, if you have a 7 cross 7 image and you are sliding over or sliding the convolution mask or kernel over all the pixel one after another, then we are saying it as a stride or stride equal to 1. And if you are going with stride equal to 2, that means you are striding by 2 pixels. Now it says that this is only possible by one formula, which says that n minus f divided by stride plus 1. If this number is an integer number, then only you can go for that number of stride. Otherwise, you cannot go for that stride for your application. Now, skipping over few slides, let me go with the concept. Now, what you have studied is you have a convolution operation. There will be a ReLU operation. I may come later. Before that, you must know what is a pooling. So it happens something like this. When you are considering a input image or input matrix of larger size, it may be possible that this large number of size matrix is very difficult to manage. Because when you are feeding it into a network, due to the size of the matrix, it may possible that the computation cost of this matrix will go for increasing. To avoid that, people thought of going for pooling operation. So what exactly it says that you can consider the input matrix into multiple segments on blocks. On each block, you compute a pooling operation. So here you can say you have a 4x4 matrix is there. I have divided into 4 segments, and on each segment, I am computing maximum value on this. So in that case, the first block you will get maximum of 20, second block you will get 30, third block you will get 112, and fourth block you will get 37. So this is the max pooling output because you are obtaining the maximum value. Again, exactly the same way, if you can take in place of maximum average value, then 12 plus 12 plus 20 by 8 divided by 4, you will get 30. 30 plus 2 plus 0 plus 0, so 32 divided by 4, you will get 8. And exactly same way, you will get 79 this block, and this one you will get 20. And this type of operation is called as pooling. Now, what exactly this pooling is doing? It is making the representation smaller and more manageable. And it operates over each activation maps independently. So in that case, 224 cross 224 plus 64 size image is now pooled to get 112 plus 112 plus 64. Because you are going for max pooling over each block to operate, and that's why your 4 cross 4 matrix is now 2 cross 2. Exactly same way, your 224 plus 64 will be now 112 plus 112 plus 64. And this is exactly what you are obtaining. This is the example. So if you are going for single depth slide, you are supposed to get this output. Now, what exactly it says that once you are having convolution and pooling, you have to go for multiple stages. After that, you flatten the data, feed into a fully connected neural network. And this is what exactly your algorithm says. And remaining was activation function, what you have understood value. So there are many type of activation functions are there, starting from sigmoid, tanh, relu, leaky relu, max out relu. So like this, many activation functions are there. And you can use any of these activation function for your application. Starting from, you have a sigmoid, which will form a transfer function like this. Tanh function will form a tanh activation function. Relu is something like this, which says that any value above 0 will follow a linear straight line equation. Below 0, it will be exactly 0. And similarly, leaky relu says that above 0, it will be linear activation function, a linear straight line, and below 0, it will be something by small negative number. And similarly, max out LU is there. This is another function. So like this, many activation function you can use for your application. In practice, usually, ReLU is mostly used. But only issue is that when you are using a ReLU activation function, your learning rate should be chosen carefully. You can use leaky ReLU, but you should not use ever tanh or sigmoid activation function, because these are although not expected to give good output, but these are supposed to give more amount of knowledge in the network. At the same time, it may give you overfitting in the cost function or overfitting process in your network. Because when you are going for such type of network, you are going for many differentiation operation to find the weight values in the network. And this will go for a overfitting of the network, or you can say a gradient, zero gradient value for your network. I'm not going details on that, but try to understand this is a challenge in your network. Now coming to the main part of the course. So you have several networks you have different CNN type architectures are there, which are popularly used for different application. It was developed in different days, a different way for different applications, starting with L05. So L05 was initially proposed in 1988. So this type of architecture has 5 layers are there. So 2 convolution layer and 3, 1 input layer, 1 hidden layer, and 1 output layer. So this type of architecture was mainly used for classification of digits or scanned digit from the number plate recognition system. So here it is taking input as a image data. It uses a 5+5 convolution, average pooling, then convolution, average pooling. Then you are flattening the input and feeding it to a neural network with 120 layer, 84 number of neurons, and 10 neurons as the output. Since you are going for divide the network into 10 possible output of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 number recognition, that's why it has 5 layers. Similarly, you have a AlexNet network is there, which is proposed or developed in 2012. So it considers the input of 224 cross 224 cross 3. So as the name implies, it's developed by some group where Alex is a person name. So network is named as Alex network. So here you have a convolution by 11 cross 11 with followed by max pool 3 cross 3. Convolution by 5 cross 5, again max pool by 3 cross 3. Then 3 convolution layers of 3 cross 3 are there. Then max pooling of 3 cross 3 is there. Then this output is flattened to 4096 neurons. Then 4096 in hidden neuron and 1000 in the output neuron is there or output layer is there. And these are responsible for 1000 different type of objects in your ImageNet database. So this is a kind of algorithm or this is a kind of network. It's called as AlexNet network, which is proposed in 2012. Next part is BGG16. So as the name implies, it's a BGG architecture. So it has different variants are there. BGG16, BGG19, and several other variants are there. This architecture was developed in 2014. So this has an input of 224 cross 224 cross 3 with a convolution of 3 cross 3, 3 cross 3 with max pool of 2 cross 2. So such 2 layers are there. Convolution 3 cross 3, convolution 3 cross 3, convolution 3 cross 3, max pool 2 cross 2. Such 3 layers are there. Then it is flattened to 4096, 4096, and 1000. It again applied to ResNet ImageNet database, which is of 1000 different categories are there and 14 lakh input images are there. So these are used for image classification process. Then coming to ResNet 50 architecture. So ResNet 50 architecture was developed with a concept of skip connection. So this architecture uses a skip connection like this, where the information from the previous layer, when transmitted to the latter layer, it is observed that during the time of transmission to the network, when you are propagating the error, this error is supposed to be vanished after few iterations. And to avoid that, this type of network is going to have a feedback connection from the input to the latter steps. Here, total 50 layers are there or 50 convolution processes are there. That's why this network is ResNet 50, and you can see the architecture for this network like this. Currently, ResNet has different variants are there, starting from ResNet 34, ResNet 15, ResNet 101, ResNet 152, 51, and then you have ResNet 18 architectures are there. So different architectures of ResNets are there. However, based on the complexity and based on the algorithmic requirement, many people don't use a large layer of the ResNet because these are very difficult to converge and very large number of parameters are involved. Mostly ResNet 50 or ResNet 34 networks are very popularly used. Next architecture is a unit architecture. So this architecture mainly implies a U type of structures. You can see here. So here in the unit architecture, the left part of the network is called as encoder or feature encoding process. And the right part is called as a decoder process. So what exactly do is, in the encoding process, different layer of convolution and pullings are used. So starting from image of 128 cross 128, it downsampled to 64 cross 64, 32 cross 32, 16 cross 16, and 8 cross 8. So when you are reducing the dimension, you are going through the process of pooling operation. So what we have done for pooling, the same operation is used to reduce the dimension of the input image. Now, once you are going to a lower dimension, you are supposed to consider any kind of, you can say, when you are going for reducing the dimension, at the same time, you are increasing the number of feature layers, or you can say number of feature you are extracting, a number of convolution layer you are using over to extract the information going on decreasing. So you can see here in the input image, you have 64 cross 64 channels are there, or you can say 128 cross 128 input with 3 channel. It is increased to 128 cross 128 cross 64. Whereas when you are reducing the dimension by pulling to 64 cross 64, the number of channel are increased to 128. Then these are increased to 32 cross 32 to 256 channel. Then 16 cross 16 to 512 channel. And then 8 cross 8 to 1024 channels or 1024 layers of features are there. And these are decoded, or when you are passing it through decoder, you are supposed to decrease, or you are supposed to decrease the number of channel and increase the size back it to 128 cross 128. So you can see here, say from 8 cross 8, it is increased to 16 cross 16, 32 cross 32, 64 cross 64, 128 cross 124. So here the encoding process is called as downsampling blocks, and the decoder part, you have upsampler is there, which is bringing back your image to 128 cross 128 or input size. So as I mentioned, UNet is a convolutional neural network architecture. It is mainly used for image segmentation, or you can say object detection and tracking part. It divides the image into different parts based on object identification. Since it is using a U type of structure or shapes, that's why it is called as UNet. It has a contracting or encoder part and expansive or a decoder part. And due to ability to performance well with a limited training data, that's why this type of image, this type of architecture is particularly suitable for medical imaging application and many other applications for your network. Next, we'll go for application of CNN. So let me go with the application part. Let me share the new slide. I hope you can see the screen.
Yes, sir.
You can see my screen, right?
Yes, sir.
Okay. So what exactly today work want to show is different 4D radar technology and advanced sensor fusion for AI application. So the contents are like this. We are going with importance of 4D radar AI, overall structure of 4D radar AI, 4D radar dataset, 4D radar AI, and future direction of 4D radar AI, what is going on. So first we'll understand function of autonomous robot. So nowadays you might be knowing that in many applications, people are using autonomous robot for your application, starting from your vehicle navigation or unmanned aerial vehicle navigation or unmanned vehicle uh, navigation. Then you have different drone control, you have different robot control, and many other things. Now, what exactly these devices are composed of is they have a perception module, they have a planning module, they have a control module. So you can think of if you have an autonomous robot is there or autonomous car is there, the perception module will include a lidar or a radar, or you can say a camera which is installed to the system. Now, what exactly they are doing is they are observing the environment, capturing the measurement or data over it, and identifying whether any object or obstacles there in the front. So you can think of some way that if you are having an autonomous car is there, this car is installed on it. Now, what exactly this radar is doing? This is trying to observe the road and identify if there is a target is there in the front or not. Or if the car is moving on a particular lane or not. So this type of task will include identify the objects in the front. Once you are identifying the object, you can plan what exactly you want to do further. So let us assume you have found it that a particular object is present in the road, then either you have to break it or navigate the way, or you stop your vehicle, or you can control it for several other way of target control values. And this function of autonomous robot is mainly applicable where you can use it for several applications starting from drone, autonomous car, unmanned aerial vehicle, unmanned conventional vehicle, robotic movement, underwater robot movement, and starting from marine or submarine movements inside the water. And advantage of this type of system is that when you are using this type of systems, these are applicable to work on extreme condition like adverse weather, fire, or smoke. So based on your adverse weather condition or several adverse weather conditions, you can consider this autonomous robot to work on different environment conditions. And that's why this importance is very high. Now, what exactly the systems are looking for? When you are saying it is percepting or the sensors are installed on this device for perception or raw measurement, it means to say that either it can be a camera data, it can be a lidar data, or it can be a radar data what you are considering. Now, what exactly happening in case of camera data is that when any object is present, the source of energy will be a light source. So light source, it emitting lights in all possible direction. It is falling on the object, and once it falls on the object, some amount of energy will be absorbed by this object, some will be reflected by the object. Now the reflected energy will be collected by a camera, and this camera will capture the information what is about the object in the display. Whereas what exactly LIDAR says that it uses some optical energy in the form of maybe infrared signal. So what it is doing is the infrared signal sensed by this LIDAR sensor will try to get an idea about the object in the front. And these are represented by LIDAR point cloud. Whereas in case of radar, radar is transmitting a microwave signal towards the object, and these signals are intercepted by the object in the front, and the intercepted signal will be received by a radar, you can say decoder, or you can say receiver, and this received signal will be used to represent as a radar point cloud. So as mentioned, LiDAR case, based on the time taken by the signal to travel back to LiDAR or LiDAR sensor, it will try to create a picture based on the distance, how far the objects are there. Whereas in case of radar, based on the time traveled by the pulses to travel back to the radar receiver, it will create a point cloud to represent how far the objects are there. Now, these radar signals are represented either as a radar point cloud or radar tensor. So, where radar tensor will go for representing the velocity of the object in the Doppler format. And this type of representations are mainly called as radar tensor or radar point cloud. Now, when we are coming to 4D radar case, definitely 4D radar case has an advantage that you are possibly represent the data in 4-dimensional space where fourth dimensions except azimuth, horizontal, and elevation, you are supposed to go for velocity as a special feature to represent the data. And it is in the form of Doppler. That's why you are going for radar tensor for representation. Radar point cloud is to represent the object in the conventional. Now coming to 4D radar dataset. So as I mentioned already, radar is a very specific application and you have several datasets are available on this scenario. There are significant role in improving the performance of AI based on the quality of data you are taking. So if you consider the radar data, you have a lot of data sets are there. And based on this data set, it is expected that we can design many well-performing AI model, which will be working a great or giving a great performance on this. Then you have a formatted data there with qualified label, sensor data with precise calibration is available on this data set with a diverse environment condition where fog is there, fire is there, and different extreme weather conditions are there. These are used as a challenge to represent the data. So there are different data are there, starting from KT data, nuisance data, YMO data. So these are representing different varieties of data with camera, LiDAR, and 4D radar representation of your different data sets. Now there are different type of tasks are there for 4D radar. The common tasks are detection of target, tracking of targets, and segmentation of targets. So coming to the first example. So detection task is to say that identify and localize the objects which are present on the or in front of the radars. So this can be called as a detection process, but we extremely say that with a different advanced weather condition or different condition or different challenges, obstacles, you need to identify and localize the object in the form of vehicle or person or lane. You need to identify them. Now, when you are going for 4D radar, so you have a 3D detection, definitely not bird eye view detection. Now, what exactly says that each level, when you want to go for train your classifier for your deep learning application, you have either class as a vehicle or pedestrian, because when you are looking for a autonomous car, you have different type of targets are there, starting from a vehicle target or pedestrian target. So idea is that you are moving with a vehicle, maybe extreme weather conditions are there. You can see here. So if you are going with a conventional vehicle system with a normal camera, so one of the biggest challenges is that your camera will not able to identify the extreme weather condition, what are the target moving in the road, starting from the person or the vehicles were moving on the road. Now my aim is to identify and localize the object which are moving on the road. So here I consider every object is represented by 3D shape. So where each object has a height, width, and depth is there. And my aim will be to find out the center point such that it is supported by height, width, and length supported by a center point. And due to motion of the object, you can go for finding the direction of the movement of the vehicle in the road. Now, what we have done is, if you are considering a camera data, you are supposed to represent something like this, whereas the LiDAR data you are going to represent on this plane. Whereas 4D radar case, you are supposed to represent the data. What I mentioned in the previous slide is 4D radar with radar tensor. So in the radar tensor form, you are supposed to localize each target with the velocity for different frame of the radar what you are computing. So this way, what exactly you are doing is you are identifying the movement of the objects in the or detecting the objects with its movement or in the different frame of the radar location where it is changing exactly. Next task is tracking. So in case of tracking, you are identifying and localizing the object within a sequence of radar images. So what exactly I am doing is I am looking for a particular target and how these targets are moving one after another or one frame of the radar to other frames in the radar, different time instant. So I am considering a particular target. I'm following what trajectory it is exactly following to different frames of the radar. And this process is called as tracking. So here, compressively, you are utilizing a sequence of detection algorithm to identify the object individually. So here we are predicting the motion of the object and data associated by different frames of the radar to represent where exactly these objects are moving. So you can see the result here. So here you are going to represent each object by a tracking ID, and based on the location of the object from different frame to frame, you are identifying where exactly it is situated. So if you go for X and Y axis, you can see here total 100 frames are there, 0, 10, 20, 30, 40, 50, 60, 70 like this. And based on the location of the target from a particular position, you can say how far this object is away from the your location or the radar location. Similarly, segmentation is another task where you are partitioning the radar data into multiple segments or regions based on certain criteria. So here, idea is that you are dividing the front end of the car into different segments. So you can see here, if your car is this one and it is moving towards front and you are identifying the front area to be segmented into multiple segments, starting from the tree area, road area, pedestrian area, pedestrian standing in the road or vehicles moving in the road. So these are different segments in the roads to be classified. And here what exactly you will get if you are going for the image data and you are dividing into multiple instance segmentation to classify different type of vehicles going in the road. And this is the code for panoptic segmentation, which will represent exactly what is available on the road. And if the same thing is represented by a LiDAR data point cloud, so this is the segmentation result we'll get. This is a road, this is a different type of tree, and this is different type of structures are there, and these are the different type of objects present in the road. Now coming to 4D radar AI, what exactly it says that when you are having a 4D radar data, you can use an encoder-decoder architecture, what I explained as a unit architecture. So here, what you can do is you can feed the data, two type of data you have. One is 4D radar point cloud and another one is 4D data, tensor data. Now, what exactly I am doing is, I am considering an encoder, and please note this encoder is mainly useful for extracting meaningful compressed feature out of your data. And what exactly this compressed feature is, this is exactly mean for bird eye view of your data. That is crucial for your application, and you are using both 4D radar point cloud data and 4D radar tensor data as input to the system. Either you can use one of them or you can use both of them as input to the encoding network. And here in the encoder, you can either using ResNet architecture or BIT architecture as a representation of your data. And when you are trying to detect the object of your interest, it can be a small or you can say large scale object, or you can have a point pillar or leader data of your own choice. So you can add your camera input and leader input to the system, and you can say that you can explore for several applications. And this encoder representation is mainly representing bird eye view feature at different scales. So this feature is not a single feature, rather it's a kind of set of features you are extracting from the encoder. And these are representing what exactly object is there and how it is associated with the scene or other objects in the view. Then you are feeding it to a decoder, and this decoder is detecting or segmenting into number of objects in the view or number of targets you are interested for. So it can be, if you are feeding a 4D data tensor data, you are supposed to get a output data with all objects are detected in 4D data tensor. And if it's a 4D radar point cloud, you are supposed to detect all the objects in the 4D radar point cloud website. Now, advantage of such algorithm is that if you are using an encoder decoder architecture, idea is that different object association locally you can model by using the feature encoder representation. So whatever encoder algorithm you are taking, you are considering for your application, it will try to model the object appearance structure, or you can say object appearance parallelly on a single platform, or you can say whole data efficiently. You are modeling different object locally by using different way of modeling the structures in all bird view images what you are, or bird eye view data what you are modeling from this encoder representation. Now, once this model, you are fitting it into a decoder, this feature encoding process where multiple targets you are modeling all together, you are visualize can, or you can visualize how the trajectories are moving one by another. So previously, the camera data and leader data, whatever you are observing, previously you are considering multiple application like detection, segmentation, and tracking to detect individual target. Now, what exactly you are representing is there, due to AI constitution, a 4D radar data is sufficient to give you exact localization or detection or segmentation or tracking all together on a single platform. So this is what exactly I already mentioned. So you consider 4D radar or tensor data or 4D radar point cloud data. Since you are feeding into an encoder, so this encoder is giving a structure based on the data type or input specific AI application you are considering. So let us assume you want to detect the object in the structure or object in the frame of the radar. So it will try to represent all the object structure one after another. And these structures are represented in a bird eye view. Then you are feeding it into a decoder. to specify or detection task or detect the objects in the scene. Not going for this. Now, case is, as you are all are aware that radar data is very scarce and it is very difficult to obtain. Now, people have used also AI or AI algorithms to generate the radar data using LiDAR or camera data, while reflecting own characteristic of radar. So what exactly we have done is, or you can say this AI algorithm has done is, so apply existing LiDAR and camera data, use some kind of data augmentation algorithm. So data augmentation is a process where you can simulate large amount of data using AI. So AI will try to generate a 4D radar data for you by using a combination of camera and LiDAR data. So you can see here, this is an example of AI generated synthetic 4D radar data. And this is the actual real 4D radar data. So you can see both the cases, the camera objects are clearly identifiable. So you can see here, there is no much difference between these two data. So where object is properly identifiable and easily captured by synthesized 4D radar data tensor, which is generated by a combination of camera data and LiDAR data. So this is a kind of application where you can synthesize your 4D radar data by combining LiDAR and visible camera data. Now, next part is sensor fusion AI. Now, idea is that many a time it came to different discussion that why only 4D radar data. Rather, we can combine camera data, LiDAR data, and 4D radar data all together, and your performance of detection and tracking or segmentation accuracy will go on improving. So idea is that you are going for hierarchical feature representation of the data, where combination of all the data will give you a better, efficient way of detection and tracking or finding the segmentation of your front view of the vehicle. Now, what exactly says that if you are considering such application, so what exactly you are doing? You are considering a camera data, either in front end camera or back end camera. You are supposed to feed it into a image backbone. So this image backbone, or you can say image encoder backbone, which will give a image feature module, which further go for a transformation module to get a camera feature module, or you can say camera based feature module. Now you can apply any kind of deep learning, or you can say any kind of your neural network algorithm to classify the target from this camera data. Similarly, LiDAR data also you can use. So LiDAR encoder you have to use, and you can create a LiDAR feature model. And similarly, 4D radar case, you can use either 4D tensor, radar tensor, or 4D radar point cloud with a 4D radar encoder to represent 4D radar feature models. Now, what sensor fusion AI is saying, that once you have all these features module are there, you can create a feature module algorithm to combine all these features. Please note. So one first feature module is representing the front camera image. The second module is composed of LiDAR point cloud or LiDAR tensor data. Third one is composed of 4D radar tensor or 4D point cloud radar data. Now all these are generated with some kind of CNN algorithm to represent the feature module, camera feature module, LiDAR feature module, and 4D radar feature module. Now, what exactly you are doing is you are taking all these features and combining these to represent a fusion feature module. So what exactly you are doing? You are taking a camera feature module, LiDAR feature module, and 4D radar feature module. And you are going to combine this based on some model to fuse the feature. So it can be appended feature like this feature plus this feature. You can say these are representing a compact feature, or you can say combination of this is to represent a future module, or you can say weight correspond to each module will be enhanced by multiplying a weight value, or you can say that there will be a weighing mechanism where which module is supposed to be given higher prioritization. You can take it for next stage. Now, once your feature module is ready, the image features are fused all together. Now, these are fed to a decoder. So what this decoder is doing, this decoder is trying to represent the object in a rectangular bounding. So you can see here a cubic rectangular bounding box is used to represent each feature or each object you want to detect and track in the scene. So what I am doing is I am trying to follow it through the decoder for doing the task. Now you have lot of weights for decoder, lot of weights for fusion module, and lot of weights are there for transformation or blue transform, LiDAR encoder, and 4D radar encoder, and image back. So I am trying to update these weights so that a optimum number of weights will be used to represent all your detection and tracking out. So this is exactly what you are interested for. So rather than considering a second feature, you are deeply coupling fusion of features starting from camera, LiDAR, and 4D radar, and sensor-wise cross-attention fusion you can consider like the feature data with camera and LiDAR and 4D radar or 4D radar camera combined together for fusion also. So many times it may observe that camera and LiDAR data is very close to each other, so they can give you a better performance, or LiDAR and 4D radar are quite better, so their combination can be give better. So that's why sensor-wise cross-attention fusion you can take, where the relation between both the feature derived from different sensors can be used to combine, and that way you are trying to fuse the model and detect what exactly target is there in the scene. Now, if you go for future direction, so several future direction of sensor fusion of AI is there. Starting from you can connecting with a LLM or large language model to create a multimodal feature attention mechanism, or you can say multimodal feature data you can create. So where you can go for different type of object, you can create text, image, LiDAR, radar, all these things you can create of your own. You can go for zero shot availability. So rather than considering any type of you can say object is not there, or you can say not going much details actually. So you can understand something like this. So you have a less amount of training samples or training data is there, and how to learn the model so that with no training data, your model should learn properly. And further, you can go for explainability, where how the model is working on your radar data and LiDAR data or camera data combination. That also you can check with your deep learning model. So this much is the what I want to represent today. So if you have any doubt, you may ask, please. So 10 minutes I am giving for question answer session. If you have anything. requesting you, if you have any doubt or anything you want to discuss here, you can, please. Okay then. Okay. Okay then. Thank you. So as you are aware that there will be a test today. So I request you please appear for the test at time. So I think scheduled time is Himanshu. What is the scheduled time for it?
Sir, 3:30 to 4.
3:30.
3:45, sir. 3:45 is okay, sir.
Okay. Okay. Then we'll be meeting at 3:45 for the test.
Okay, sir.
Thank you, sir.
Oh. And the question paper will send by mail. So you have to answer it and then you have to send it back by the mail so that we can evaluate it. And it will be a you have to switch on your camera so that we will proctor it and I can check if you are not copying from any other source. So we'll check by that. Thanks a lot. So thank you.
Thank you, sir.
Hello, everyone. I hope you can hear me.
Yes, sir.
So, we are sending you the question paper by the mail ID by which you have registered for the workshop, and you have to return back this answer set by I think half an hour means 3:15. Please try to return back the answer sheet or answer of each question by mail. It is fine. It all are MCQ type question. So there will be 30 questions will be there, and you have to answer all the question. And either you send question number 1A, 1B, 1C like this in email, or you can put mark on that what is that question paper and send it back to us. So we are sending the question to you. It started now. Okay. Hope you have received the question paper. Please just check.
Not yet, sir.
Okay. Okay. 1 second. Hope all have received the question paper now. Can you please?
Yes, sir.
Now you have to answer the question and you have to
Sir, I
send
have
it.
not received the paper, sir. No. Received, sir. Received.
Okay, okay. If anyone has not received, please confirm.
So shall we take printout of it?
It is not required to take printout. You can use the soft sheet, soft copy, and you put the answer on that and send me that same paper. Or you can send directly the answer of each question 1A, 1B, 1C in the mail itself. There will be no problem. Hope it is clear.
Sure, sir.
Anything is your wish. If you want to feel better to print it and scan it and send it, that is also fine with me. I don't mind. Feel free to use your technology.
Okay, sir.
Okay, and please switch on your camera, please. Please switch on your camera. Please all switch on your camera.
So am I visible?
No, no.
So I'll sign out and join again, sir.
Okay. Debrat. Himanshu.
Yes, sir.
Please switch on your camera. Bhanu Teja.
Bad. You can see me.
Yeah. Dr. Yashwant Ayushi.
Excuse me, sir.
Yeah.
Excuse me. Sir, where do I submit these answers? In a Word document?
So it is fine. You can submit in a Word document or directly paste in the mail also you can send it.
Okay, okay, okay. Thank you, sir.
Same mail on which you got the question paper, you can.
Yes, I got it and I'm solving it. Fine.
Oh.
Okay, fine. Thank you.
Where do I have to send the response?
Same email ID from which you got the question paper, please send the email. Please email your answer to that email address.
Thank you, sir.
And please don't leave the exam because 4:15 will go for validatory. Rather than delaying it further, once the exam is over, we'll go for validatory. So that we'll complete.
Hello. Uh, hello.
Yes, yes,
Uh,
Pranav.
sir, I have mailed you, but the issue is that I have not put the section. I have like there are 4 sections, and I have forget to mention one section.
Even
Should I
six.
email you?
You have made it
Sh-
question number one,
Send
two,
you?
three like that, right?
What?
Question 1, 2, 3 like that, right?
Yeah, 1, 2, 3, 11 I have done, but after that, the just the second section, I have forget to put the name of that section of the resistance, like of
Better
all
you
the
send
now.
a single mail with all answers, not
What?
separate.
No, no, I have sent the answers of all the questions, but I forget to mention the second portion of the question,
Okay, no issue, no issue.
the memo does. And the third and all are correct things, but that I forget. Should I resend?
Mm-hmm.
Okay,
Please
sir, I
resend.
will resend. Okay, sir. I will.
Hello, sir. Hello.
Yes.
Sir, can I share this answer in message form?
Message form you can share also. Your wish. That is not a big issue.
Okay, thank you, sir.
Sir, kindly check. Have you received my mail?
Wait, let me check.
Hello, sir.
Yes.
Sir, can I turn off my camera? My exam is over.
क्या?
Can I turn off my camera?
Yeah, you have submitted already, right? Let me check.
Thank you,
Actually. By that time, you can turn off. No issue.
Sir, please check if you received my mail.
You have sent. Now I cannot check one after another. That's it.
Yes, thank you, sir. Can I switch off the camera?
If you have sent, we'll check it. Okay. If
Thank
we
you,
will
thank
not
you.
receive, then we'll inquire. Okay.
Thank you, sir.
Sir, I have sent it. Submitted the answer through mail.
Okay. 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 time up. Please submit your paper. Please submit your paper. Hope everyone submitted. Pallavi, have you submitted?
Submitting, sir.
Submitted. Okay. Okay. So let us conclude the program actually. So previously we planned the program conclusion at 4:15 or 4:30. So let us conclude now. If it is fine, let us conclude now. So first of all, thanks a lot. Thanks a lot to Professor Sabrina first, who has taken all the pain to give time on this course, because she is a very busy person, and she is involved in many activities starting from many editorialship of many journals and many academic roles and many committees in the international level. Till that she was able to manage her schedule to deliver this lecture. I request all of you, if you have any queries or you can say any feedback on the course, please suggest us. Whatever you feel about the course, you can please suggest or you can give your feedback. I hope I am audible.
Yes, sir.
If you have any feedback, kindly suggest. Okay, okay, I can get that nobody has any positive feedback or negative feedback too. So first of all, thanks a lot for attending the course. We will send you the certificate, and before that, there is a requirement that you have to give the feedback about the course. So we will be sending a feedback form to you. You have to submit the feedback form, and kindly note, without feedback form, we will not able to give you the certificate as per the ministry confirmation. And second thing, we will also send you the grade sheet, whatever the exam you have attended, and both the things you will get by mail. And if you want a hard copy, if you are available in Jammu, we can also provide you the hard copy of the certificate. And if not, then we'll be sending you the soft copy of the certificate by mail. If no point from anyone, then let us close the session. Thanks a lot. Open to any feedback from anyone. If not, then we'll close this session. Okay then. Okay. Thanks a lot. Let us close the session.
Thank you so much, sir. Thank you so much.
Thank you. Thank you.
Thank you, sir.